All right, let's look at this example. A 5 meter ladder is resting against a vertical wall. Suppose the ladder begins sliding down the wall in such a way that the foot of the ladder is moving away from the wall. How fast is the top of the ladder descending at the instant the foot of the ladder is 4 meters from the wall and the foot is moving away at a rate of 2 meters per second? What? Well, I don't know. So let's draw a picture. All right, here's my wall right here, okay? Here's my ladder. Let's suppose that we have the ground that's level. So I'll get a 90-degree angle right there. Now, here's how far up the wall my ladder is right here, okay? I'm going to maybe call that Y right there, how far up the wall my ladder is. All right, let me see if I can label anything else. A 5 meter ladder. So this ladder, I'm going to call that 5 meters. 5 meter ladder is resting against the wall. Suppose the ladder begins sliding down the wall in such a way the foot of the ladder, so this foot is moving away from the wall. How fast is the top of the ladder descending? Okay, what are they asking? How fast is the top of the ladder descending? So they're asking for a rate again. How fast is the top of the ladder descending? So that would be the change in what? That's going to be this value here, or the change in y with respect to t. They want to know, what is that value? How fast is that descending? At the instant the foot of the ladder is 4 meters from the wall. At the instant this foot right here is 4 meters away from that wall. Well, I need to call this something, this part of my triangle. I can't call it 4 because that's only at one certain point. It's changing, right? If that ladder's sliding down the wall, this length is changing. So I'm going to call that some variable like x. Now let's see. How fast is the top of the ladder descending at the instant the foot of the ladder is 4 meters away? So whatever x is what? 4. So I want to know this whenever x is 4. Okay, at the instant the foot of the ladder is 4 meters from the wall and the foot is moving away at a rate of 2 meters per second. So what does that tell me? If the foot is moving away at a rate, that tells me it's going to be a derivative, right? What's it going to be the derivative of? What's changing here? X. So it's going to be dx over dt. And what is that value going to be? The foot of the ladder is moving away at a rate of 2 meters per second. All right, so what do I have here? dy over dt I need to find. dx over dt is given to me, but I'm going to take the derivative of an equation with respect to t. So what is that equation? Well, it's going to need to involve y, and it's going to need to involve x. Look at this triangle. Think of an equation that involves y and that involves x. Right triangle, I know the length of this side, I know the length of that side, or I don't know, I'm just going to say the length of that side's x, the length of that side's y, and I know the length of the hypotenuse, right? So it's like the Pythagorean theorem. We can say x squared plus y squared is equal to 5 squared, right? According to this right triangle. Now that's an equation with y and with x in it. And I can take the derivative with respect to t of that thing. Let's do so. Let's take the derivative of this part with respect to t. That'll be 2x to the first times dx over dt plus, how about this part? That'll be 2y to the first times dy over dt. What's the derivative of 5 squared? 0. All right, let's fill in for some stuff we know. Okay, right here we're going to have 2 times x. What is x at this instant? 4. Times dx over dt. What is dx over dt? 2. Plus 2 times y. What is y? They don't give me y. How about dy over dt? dy over dt is unknown, so that stays dy over dt. is equal to 0. Now right now, this is still y, right? There's too many unknowns to solve for, too, right there. So let me find out what y is. How can I find out what y is? Well, y'all just told me that. We can use the Pythagorean theorem, right? And x squared plus y squared is equal to 5 squared, right? But what am I looking at? I'm looking at the instant that x is 4. When x is 4. So I'm going to put when x is equal to 4 here. What will y be? Let's see. Let's sub in a 4 here. 4 squared plus y squared is equal to 5 squared, right? So that's 16 plus y squared is equal to 25. Now I'll get y squared is equal to 9. And if I take the square root, I get y is equal to what? 3. So when x is 4, y is what? 3. So whenever x was 4, this y becomes 3. Now what am I trying to solve for? dy over dt. So let's solve for this portion right here. Well, 2 times 4 is 8, times 2 is what? 16 plus 6 dy over dt is equal to 0. Or I could say 6 dy over dt is equal to negative 16, right? Let's keep going. So if I divide both sides by 6, I get dy over dt is equal to negative 16 over 6, or if I simplify, dy over dt is equal to, I can divide it both by 2, so I get negative 8 over what? 3? Negative 8 over 3. Now, what are my units going to be? The units of y over the units of t. What is y being measured in? Meters. So meters per, what's my time measured in? Seconds here. I think I erased it where it said, but it's seconds. Now, does that make sense for dy over dt to be negative? How's y changing? It's decreasing, right? So it does make sense. Now, let me see. What did they ask for here? How fast is the ladder descending? So if you were going to write like descending at a rate of 8/3 meters per second, you would go ahead and put in that, okay, descending, because that automatically implies it's negative, okay? Then you would put a positive there.